Hello everyone, welcome to your favorite YouTube channel, My Project Ideas. Today we are going to work on a fresh new topic that is recursion, and we are going to look at the introduction of this. So I hope you guys are with me. So cheer up, gear up, and let's move to the next slide. The first question that should arise in your mind is, what is recursion? Recursion is a way to solve a problem or a way to write a program in which a function calls itself directly or indirectly. So what's recursion? Recursion is a way in which a function calls either in a direct manner, it can be a direct call or an indirect. It's called a function call. So using these recursive algorithms, certain important and complex problems like towers of Hanoi, pre-order, post-order, in-order tree traversals, and the depth first search, that is DFS of the graph, can be solved. I know it's a bit tough, right? So what we are going to do is, now we are going to look at the recursion algorithm only. When we will move towards graph and tree and stuff like that, you are going to have a clear look at it. Okay? So now I told you about that a function can call itself either directly or indirectly. So if a function calls itself directly, what is it called? Direct recursion, simple. And if a function calls itself indirectly, it's called an indirect recursion. Look at the example in the table given at the bottom of the screen. In the direct recursion, the fun one, that is the function one, is calling itself inside the fun one. That is simple, pretty easy stuff. But in the indirect recursion, inside function one, function two is there, and function two is another function which is written after the block of function one. And inside function two, function one is. So here a function is not calling itself inside the block, but outside of another, outside of the block, outside of its block, but in the block of another function. Now, what is the need of base condition in recursion? So let's code to find out how does this recursion look like, and then we are gonna have a look at what is the need of the base condition recursion. So let's move to our VS code as we do in all our videos. It will take some time to open, hang up. So what you guys can do is, you can also write a simple algorithm for recursion. Then you can come back and check mine. So what we'll do, we'll create a new file. Here we are. Okay, the name is recursion. Let's keep it recursion1.tiny. Okay, let's write the code. So first we're going to declare a function called def fun1. Then let's print something. Print, say, what can we print? My project ideas. Okay, cool. Then we can call this function. Okay, good to go. Then we can write the base conditions, or you can write the driver code. So let's write it. If name is double equal to your name, what are we supposed to do? We're supposed to point it. Okay, done. Now let's save it and let's run. Let's see what is the output. The output is C. So the function is calling itself and itself and itself. So it's an unending type of thing. There is no end of it. Why? Because I haven't given any condition. So what is the need of the base condition, guys? Because if you do not put any base condition, it will fall into a like an infinite loop. There won't be any end of the recursion. So what happened here is, the above function have an issue. What's the issue? They recursively call themselves without any base condition or a breaking condition, leading to a segmentation. In a recursive program, the solution to the base case is provided. Always you have to put a base condition. If it is not fulfilled, the recursion should end there. Otherwise, it will cause a segmentation fault. Keep that in mind. It's important. Now, let's put a base condition and let's check if our code is working fine or not. Let's see. So what we're going to do is, we're going to move to our code editor again, create a new file, write recursion2.python. Okay, created. Fine. Good to go. The functions again. Def fun1, put n. If n is double equal to 0, you can turn. So this is the base case, guys. If n is double equal to 0, that is the base case. You are checking basically if n is equal to 0 or not. Simple. Now let's print. Again, let's print my project ID. Now let's write or call like recursive call the function. So in each iteration or in each recursion, the value of n will be decreased by 1. Now let's write the base case. If name is double equal to, this is basically my first number, the input that I provided. We save it and we got the output 2 times, because for 2 to become 0, you need to recursively correlate twice. So it writes my project ideas, my project ideas. Got it? Good. Let me clear the terminal. Read this and let's move to a PPT. So here I gave the input as GFG, so it showed GFG. In case of recursive functions, the function is called again by itself only. The function calls itself. So if you have a base case, if that's true, you go to another go to the solution of that. If it's false, you go to the next line. See here, in this, if x is double equal to 0, this is a base case. If it's true, you go there. After this, you go at the end of the if block. If this is false, you go directly to this recursive call. It's pretty simple. This is just if else condition, that's it. So how memory is allocated to different function calls? So the memory basically is allocated to the stack. We are gonna read about the heap, stack, everything in the upcoming lectures. So don't worry about it. Just remember it's allocated to the stack. When your base case is reached, the function will return the value to the function by whom is it called, and the memory will be deallocated and the process will be continued. Simple. This is a typical structure of a recursive function, and this is how the memory, so illustration of the memory and recursion stack. First, the function will be called from main. Second, there will be recursive function calls. Then there will be return and deallocation, and finally your base case will arrive and your recursion calls will be stopped. Great. This is a factorial function. We did it in iteration. We did it by loops. You can do it via recursion also. So first, what you will do, you will call it initially. Suppose factorial 3, a stack frame will be created. In case of recursive calls, first factorial 3 will be reduced to 2, 1, then 0. Then your deallocation, return and deallocation will be there, and finally you have a base case. Okay, let's do one thing. Let's code it and let's see if we are on the right track. Let's see. Let's go. Create a new file. Write recursion 3 Python. Great. Now let's create def your print function. Let me give a value test. So if your test is less than 1, you can write return else print test comma and equal to space. Okay. Print fun. Let's print again. Print your test and again end is equal to space. Now if name is double equal to then let's keep the base case. Test is equal to the input 3 and let's print function. Let's save it and finally let's run it. So you got the output as 3 to 1, 1 2. So let's check if this is the output that we expected. Yes. Now what happens here is, first in the first recursion, the first function, when in the first iteration or in the first recursion, your print function 3 calls print function 2. In the next type, the next section, print function 2 calls print function 1. Then again, the print function 1 calls print function 0. And finally, when you're returning, what happens is it returns the value to print function 1. This function returns the value to print function 2. This block returns the value to print function 3. This is how we get the output. What are the disadvantages of recursion, guys? It takes a lot of space because it will remain in the stack until your base case is reached. Then your time requirements, they have a higher time over it. What are the advantages? It's simple and clear, that is simplicity and clarity, and it's a natural fit for various problems like tree traversals, tower of Hanoi. So these are the model problems which will can be easily solved by recursion. End. And I hope you understood everything. I hope this is pretty clear to you. And let's wrap this session for today. Until then, until next video, I hope you guys have fun. Keep coding, keep learning.